And welcome to the second video on the first lesson of Unit 2, which is derivatives. That was a mouthful. So in the video you just watched, we talked about really a numerical approximation of a derivative, getting closer and closer so that 2 points are really, really near each other. And so if we want to think about points getting closer and closer to each other, what we're really talking about, just as a review, is a limit. We're taking a limit of 2 points A and B, or 2 points A and X, two X values, that as they get closer together, you can find the slope between them to approximate or eventually truly find the instantaneous rate of change at a specific point. So we're going to go through and we're going to do that algebraically instead of numerically right now, using that limit definition of a derivative at a point. So this one says I have f of x equals 1 over x plus 1. And it says find the slope of the curve at x equals a. So the slope at x equals a is really, where's my draw button? There we go. Is really saying what is f prime of a, meaning what is the derivative at point a. Okay, and f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. And so now I'm going to evaluate that using the f that we have. So f of x, and I realized I said so a lot the other day when I was watching one of my videos, so I apologize for that. I'll work on the sheer number of so's that I say and try to make that a little bit better. So I have the limit as x approaches a, I did it again, of 1 over x plus 1 minus 1 over a plus 1, pardon me, got plus happy, over x minus a. Now, right now, if I evaluate this at a, I have 1 over a plus 1 minus 1 over a plus 1 over a minus a, and that's going to be 0 over 0, which tells me I should be able to maybe find a way to simplify this and maybe divide and cancel. So let's try to see if we can do that. I am going to do that by simplifying by multiplying the numerator and the denominator by the least common denominator for those two fractions. And so when I distribute that LCD, I end up with the limit as x approaches a of a plus 1 minus x plus 1 divided by x minus a, x plus 1, a plus 1. And then if I simplify that, a plus 1 minus x minus 1 is really going to take these ones and they'll add to 0. So in the numerator, this really becomes a minus x. And a minus x divided by x minus a is really negative 1. And I'm sorry I didn't leave you more space here. What was I thinking? So then I have the limit as x approaches a of negative 1 over x plus 1, a plus 1. And now if I evaluate that at a, I have negative 1 over a plus 1 squared. Okay. That right there is a function that when you plug values in for a, you will get the slope of f at a. That is, in effect, the derivative. So it says find the slope of the curve at 2. This is an expression that will find the slope of a curve at any point. So I'm just going to plug 2 into there. So f prime of 2 is negative 1 over 2 plus 1 squared, which is negative 1/9. Cool. Find the equation of the line tangent to the curve at 2. To find a tangent line, you only need 3 things. You need a slope, you need an x, and you need a y. And preferably, when you're finding a tangent line, your slope comes from your derivative, and your x and your y come from your point of tangency. Well, I have the slope, that's negative 1/9. I have the x, that's 2. Now I need a y. the y always comes from your original function, because that's the thing you're trying to be tangent to. So f of 2 is going to get me my y value, which is 1/3. And so now I have an x, a y, and a slope. I'm going to use point slope form. Y minus y1 equals mx minus x1, which is going to be y minus 1/3 equals negative 1/9 x minus 2. Then it says find the equation of the line normal to the curve. On the notes in the previous video, we said tangent lines are really parallel to the curve, but they touch it once. Normal lines are going to be perpendicular to the curve, but they're going to go through that point of tangency. So my x1, y1 doesn't change, just my slope change. Perpendicular, opposite reciprocal slope. So y minus 1/3 equals positive 9 x minus 2. Cool. Let's make sure that this looks the way I say it looks. I'm going to, whoa, I flipped upside down. I don't know if that flipped upside down for you, but it did for me. I'm going to go to Mrs. Vibber's favorite website. Say it with me, kids. Desmos. So Desmos, graph. My original function, f of x, was 1 over x plus 1, not 2, 1 over x plus 1. Let's see, my point of tangency that I was looking at was 2 1/3. So there's my point of tangency. I gave it extra parentheses for no apparent reason. And the equation of the tangent line was y minus 1/3 equals negative 1/9 x minus 2. Y minus 1/3 equals negative 1/9 x minus 2. Hey, that looks pretty tangent to me. Cool beans. And then I said for the normal line, it's really that same equation, but a 9 instead of a 1/9. This is pretty perpendicular too. Awesome. Success. Now, there was another question here. It said, find the x value where the slope is 1. So I want to know when the slope is, negative 1. Not so sure about that. Well, I am sure, I'm thinking. But if I wanted to figure out when the slope was 1, the slope comes from the derivative. Oh, I just want to know when the derivative equals negative 1. Flipping again. So I'm going to take that derivative, which was what now? Negative 1 over a plus 1 squared. And I'm going to set that equal to negative 1. Now, this is one of those times where I've talked about it in class, and if I haven't yet, I'm talking to you now. Over your years of mathematics, we've taught you skills and routines, and your first thought may be, put that over 1 and cross multiply. Please stop doing that. Please stop doing what you were taught to do, and pretend for a moment that over all your years of mathematics that you were taught to think first and then do some math, rather than writing down algebra that you don't need. Let's think first. If negative 1 divided by something equals negative 1, doesn't that just mean that a plus 1 squared has to equal 1? Right? Yes, Mrs. River, that's exactly what it means. Okay, don't cross multiply. That's silly. You're wasting your time. And if a plus 1 squared equals 1, that means either the a plus 1 was 1 or a plus 1 was negative 1, which means a was either 0 or a was negative 2. There you go. And if you're curious about, well, how could I prove that? I could go back to my favorite place. If Desmos was a place, I would live there. So I'm going to go to a equals 0 and see if my slope really is negative 1. So I'm going to make a point here, and I'm going to make that point a comma f of a. Oops. And I'm going to add a slider at a, and here's that point. So it's right here. Cool. And I wonder if I could make an equation. You know what, guys? We're going to figure this out together because I haven't tried it. I want to make the tangent line there and see if that slope looks like it equals negative 1. So at that point, the tangent would be y minus f of a equals m. Well, m was the slope, and the slope was -1 over a plus 1 squared. Hey, I'm at a tangent line. It's going to move with it. Woohoo! All right, let's move it around and see if that slope's -1. Well, if I put it right here at a equals 0, what just happened to my voice? Hey, that slope does look like it's at -1. Cool. And if that works, then a equals -2. Maybe that would also work. So let me slide my slider down here to a equals -2. Hey, look at that. My slope looks like it's -1 there also. Let me change my status to do not disturb so these pop-ups stop occurring. We did some cool stuff. All right, this video is kind of getting long. So let me try to wrap this up and go faster in the bottom one. Example 2. I'm just going to fly through this one. If you think you know what to do, feel free to pause me and then come back and check in. Blue. I really want blue. Find the slope of the curve at a. All right, so the slope comes from the derivative, and I want the limit as x approaches a of f of x minus f of a over x minus a, which is going to be the limit as x approaches a of x cubed minus a cubed over x minus a. And those are 2 cubes, so I can factor using the formula for the difference of 2 cubes, which is that SOAP thing. Same, opposite, always positive, which is x minus a, x squared plus ax plus a squared divided by x minus a, which is now the limit as x approaches a of x squared plus ax plus a squared. And if x is approaching a, I can replace all the x's with a's and get a squared plus a squared plus a squared, which is 3a squared. So my derivative at any point is the square of that number times 3. All right? Find the slope of the curve at x equals 2. I'm really finding f prime of 2, which is 3 times 2 squared, which is 12. Find the tangent line at 2. A tangent line needs an x, needs a y, needs a slope. I just got the slope. I just got the x. I get the y from the original function. So I need f of 2, which is 2 cubed, which is 8. Y minus y1 equals mx minus x1. There's my tangent line. Find the normal line. Keeps the same setup as the tangent line with an opposite reciprocal slope. Find the x values where the slope of the curve is 12. Well, if I want the slope to be 12, hey, that's what I already had. I needed 3a squared to equal 12, which means a squared is 4, which means a is plus or minus 2, and I already had one of those. Hopefully now you feel like you understand how to use this derivative formula. Good news, kiddos. This is the last day where I make you do it the long way using the limit definition of the derivative. Well, actually, that's a lie. This is one of the last days, but you will not have to do 40 different derivatives when you have to write it out and try to factor and cancel. That is a waste of your time and my time, and I'm not going to make you do it. I'm going to make you do it a couple times, but I'm going to say at most 2 more times, and then once we get to trig, I will use the limit definition of the derivative and have you follow along. What keeps a tree from moving? Square roots. I screwed up that joke. What keeps a square from moving? Square roots. I can't even tell good jokes today. I'm going to sign off for now. Have a good one, everyone.